Today we talked about various methods of solving for pH, pOH, and things like that. So these are the 4 equations you've so far learned. So we started with our Kw equation, where you find Kw by multiplying together the concentrations of hydronium and hydroxide ions. And remember that Kw is always a constant value of 1 times 10 to the negative 14th m squared. We then learned that you can use the hydronium ion concentration in a logarithm to find pH. You can also use the hydroxide ion concentration in a logarithm to find pOH. And then relating pH to pOH, they always equal 14 when added together. So the next couple examples are just using all these equations at once. And yes, I do want you to do it the long way, because as I said in the last video, I want you to know how to use all methods. If the document does not specify which method or equation I want you to use, you can use whichever. But for the documents and the worksheets you're working on in the near future, I want you to do the long method to practice. So this is continuing from the last examples, which is why it's example 3. But it says find the hydronium and hydroxide ion concentrations, as well as the pH and pOH of this solution. So the first important thing is obviously the concentration given to us and the substance. So this is our molarity, and this is our substance. So those are the 2 most important things to start with, the things you have to start with. So we need to know, is this concentration given to us? Let me get my pen here. Is this concentration representing the hydronium or the hydroxide? In that case, you have to look at the substance. So we have HBr, which is an acid, hydrobromic acid. So in this case, because this is an acid, this molarity is actually equivalent to the hydronium ion concentration. So we already know one thing right off the bat, and that's always the case. So I'm going to make a list over here. And I would actually appreciate if you could make a list so it's very easy to find all 4 of your answers when you're done. So I'm just recopying that molarity into my hydronium ion concentration since it's an acid. So the first thing I have to do is use this Kw equation to find the hydronium. I'm sorry, that's wrong. To find the hydroxide ion concentration. So that's step 1. So I know Kw, constant value, is equal to the hydronium ion concentration given to me in the problem, multiplied by my hydroxide ion concentration, which I do not know yet. So obviously I'm going to divide both sides by the hydronium ion concentration. Show your work, show your units. And that's going to get me my hydroxide ion concentration. Okay, so in your calculator, 1 times 10 to the negative 14th divided by 5.8 times 10 to the negative 2nd. And remember, you can always use the E button to take the place of times 10 if you don't like that much typing in your calculator. I also think it makes it easier and causes less errors or mistakes. So solving that in your calculator, you would get the hydroxide ion concentration is equivalent to 1.72 times 10 to the negative 13th. And that should make sense. The hydronium ion concentration should be much less than the hydroxide for an acid. So it seems like we're on the right track. Also remember, you can check your answers by multiplying these 2 together, and you should get close to the Kw. So step 1 taken care of. Now I need to solve my pH and my pOH. I'm just going to do pH first. So pH is equal to the negative log of the hydronium ion concentration. So plug that in your calculator. So for my pH, I get an answer of 1.24. Okay, now you have 2 options. I gave you this equation and I gave you this equation. do whichever one you want. I'm going to do both. So the last thing is solving for the pOH. So if you want practice in the long way, pOH equals the negative log of the hydroxide ion concentration. Okay. Or you could use this equation where pH plus pOH equal 14. So we said the pH was 1.24. I don't know my pOH, but I do know they both have to equal together 14. So you could use either method. You don't have to do both. I would definitely practice both, especially the logarithm, because typing that in your calculator sometimes causes issues. So either way, it doesn't matter how you do this, you're going to get the same answer. pOH equals 12.76. If I add these together, I get 14. That's how you know you're right. So you can always check that way. Okay, and once again, the pH is 1. That makes sense for an acidic solution. So these are the 4 answers I need to see very clearly for these type of examples. It's just using everything you've learned so far in this chapter together. Okay, let's try another one. So once again, you're finding pH, pOH, and both hydronium and hydroxide concentrations. So the first thing you need to know is the substance and its molarity. So here's that information. So is a substance given to us an acid or a base? This is a base, sodium hydroxide. So that means that this value is OH minus. You've got to get those little tricks down. So let me make my list. Remember that the hydronium and hydroxide ion concentrations have a unit of capital M. pH and pOH do not have a unit. So the first step is to use this equation. I know my Kw value, I know my OH minus concentration value. I am solving for the hydronium. So you're going to divide both sides by the OH minus concentration. So go ahead and do that. Make sure you're typing in your calculator correctly. And solving for the hydronium ion concentration, I get and I apologize if I messed up there. I meant to say that you divide both sides by the hydroxide ion concentration to solve for the hydronium. So here's my hydronium ion concentration. Notice it's a smaller number, which makes sense for a base. Now I can use either equation to solve for pH or pOH first. So let's do pOH first because why not? Doesn't matter which one you solve for. So I'm choosing to solve for pOH first, but you could solve for pH first. So go ahead, pause the video, work out pH and pOH, and then come back and see if your answers are correct. So for pOH, I get a value of 1.06. And then remember, now I'm solving for pH. You can either use this equation, negative log of the hydronium ion concentration, or you can use pH plus pOH equals 14. Either one, you're going to get the same answer. So solve for that, see what you get. I have my pH as equaling 12.94. Adding the 2 up gives me 14, so I'm good there. My pH is above 7. That makes sense for a basic solution. So once again, all 4 of my answers there with the appropriate units, if any. Okay, try another. All right, I actually lied. That was the last example. So only 2 examples for this video. I apologize for that. So once again, you're using all the equations you've learned so far to find pH, pOH, and the hydronium and hydroxide ion concentration, and you're always going to be given one of those concentrations in the substance.